oh, this virtual machine's in the middle of booting at that. Fortunately, throughout the talk, I close Windows and it speeds everything else up. But yeah, the only way I found I could get everything working is to have everything pre-booted. Otherwise, we'd be waiting for 10 minutes for it to boot. During demos.
I guess it crashed before you started.
Yes. I accidentally bumped the screen close.
Mike's actually live.
Yeah, I know. Shit, the last thing I need to do.
Yeah. I'm ready to go.
All right.
Oh, he's. So I'm going to ask some trivia questions. The first person to raise their hands and get called upon with the right answer will get a copy of Steal This Computer Book 4.0 from Wallace Wang, donated to us from No Starch Press. So the first trivia question I have is, what does the stir fry function do in C? There is a string function like stir copy. Stir fry was somebody in the hand that I can't see. No, unfortunately it doesn't make tasty food. Anybody else have an idea what the stir fry function does? Yeah, come on, go ahead and stir fry takes a string, a C string, and takes all the characters and using a very bad random number generator, mixes all the strings to it. One of the most useless functions in libc. All right, for our 3 o'clock talk, we have Seth Fogie from AirScanner. He will be talking about Windows mobile software to run on your new fancy cell phones, what they can do, what they can't do, and hopefully how to break them. So, Seth, everybody, big hand for Seth.
All right, welcome to the talk. I should mention that during the talk, I'll be giving out 6 books. But because I'm a mobile guy, I don't carry around books. I carry around business cards, and they have a name of a book on them. To get one of the books, I'm going to have audience participation, throwing out questions, and see who can get them, get the right answer. As you said, my name's Seth Fogie. I come from AirScanner. I work with InformIT.com, and they're the ones that donated the books. It's basically a subsidiary of Pearson Publishing. I also do a lot of writing for various other publishers, too. With my work with AirScanner, I do a lot of work with Windows Mobile research and security testing, and that's how I am up here. So as a quick overview, we're going to look at the past, what's already been done, what you need to know in order to get up to par if you want to start doing this. Then we're going to look at some information disclosure issues as far as keeping the data safe on the device and the programs that say they do it but don't. We're going to look at a smorgasbord of other issues and hacks and tricks and bugs and fun stuff. And finally, we're going to look at local remote exploits, including the Windows Mobile 5 code signing and ways to bypass that. This is a review. The first, pretty much the headlines that came out were Ratter with the Dust virus. It was a real pivotal point for Windows Mobile device security because he found this kdata struct function, which basically allowed you to gain access to every single other function in core DLL, which is kind of like the kernel of the Windows Mobile device, dynamically on the fly. Now, this has gone away in Windows Mobile 5. But for all the older devices, it still applies. I then did a presentation at Black Hat, covered shellcode, had a buffer overflow example, keyloggers, hidden backdoors, a whole bunch of basically looking at ways the malware could be placed onto a Windows mobile device. Sans, he did a lot of work with the Windows CE environment as far as creating shellcode, demonstrating a buffer overflow, and kind of build on that. Now, these 3 guys are all part of the Trifonite group, and they've done a lot of good work. Colin Mollimer, he's been involved in Windows Mobile security scene for a while. He came up with buffer overflow that would dial numbers. His latest exploit was the Tmail exploit, and that actually was a remotely exploitable buffer overflow that via MMS message that would at least cause the potential to have buffer overflow code or shellcode running on the device. Tim Herman, he really went into some CE shellcode and basically created shellcode that could run more shellcode, and found some other really neat features and problems that he was able to work around with building buffer overflows for Windows Mobile. And Kevin Finisterre, he also, with the many other things that he does, he also found time to go ahead and find Bluetooth exploits on PDA, depending on the Bluetooth driver that you have. So that's all been done. This presentation is basically as a result of, can I find at least 99 programs or problems in programs that are out there in existence? And I'm talking about not just the core device itself, but all the software that people install in it, because that's what really makes a Windows mobile device so much fun, is that you have up to, 18,000 different applications that can go on one of these devices. And this is the result of that project. So why does this matter? Well, first, the Windows mobile devices often kind of slip beneath the policies. They aren't really truly understood as far as the security risk. They're not taken seriously, or they're just plain old overlooked. And then there is what I call the multi-user base. This isn't about somebody gaining root on your box. It's about the mobility factor. 24% of these devices get lost, so the data on the device has to be kept secure. If you trust programs to keep that data secure, well, I sure hope it does that. But as we find that a lot of programs really don't. Anyway, so if you have access to the device for even 20 seconds, you can do all kinds of fun things and gain access to all kinds of data. So the tools that I used, and you might want to use too, in Windows Mobile 4.2, 2003, embedded Visual C++ worked great. It was free. It had a debugger. You could basically plug in any executable you wanted to take a poke at and launch it, and it would allow you to gain access, and you could do breakpoints and everything else. But Windows Mobile 5, you can throw that out the window. Now you got to get Visual Studio 2005. But it's not straightforward. You have to actually build a blank program, rip out the debugging information in the exe, drop in the exe you want to target, and then launch it and trick the debugger into thinking that it actually has the original exe. So, and it still doesn't include disassembler, and there's problems with even doing it that route, where you have to actually insert code into your buffer overflow to cause the program to have an exception to stop it from executing. It's complex. Thank goodness for IDA or IDA Pro, because it is the godsaver when you want to debug Windows mobile applications. You can debug, you have all the IDA functionality. It doesn't crash on ROM DLL access issues. It does cost some money, but it's well worth the cost. It doesn't work on everything. It, for example, won't work on my Windows mobile device here. It just, you try and connect to it and it dies. Now, there are some workarounds for other issues, but the nice thing about it is you don't actually need a phone to work with IDA. You can go out and get a copy of Visual Studio 2005, download the SDKs for Windows Mobile 6, Windows Mobile 5, smartphone environments, and you can just use those SDKs, and IDA works perfectly fine with those. So you can still play with all the devices without actually having to own a device. So instead of investing in a device, invest in IDA Pro. So real quick, the registers. There are 16 registers. R0 through R3 are used for parameters when you have a function call. If there's any more than 4 parameters, then they will get placed on the stack. Stack pointer address is located at register 14. Register 15 has the program counter address, which is the address being executed. Pay attention to your condition flags. They control the flow. The opcodes are pretty easy to understand. If you spend about 15 minutes in IDA with this, you'll be able to figure those out pretty quickly. There's a lot of memory and system issues you need to be aware with. But again, go back to all that review stuff. I'm not going to spend time going over it here because it's already been done. And this little link at the bottom here is a great shortcut for kind of like a cheat sheet for ARM and stuff. Now, I'm going to go through this really quick. This talk is about a 70-minute, maybe 60-minute talk, and I have about 45, 50 minutes to do it in. So let's get started. First is plain text passwords. Not a big deal, not really lead or anything, but they do exist en masse on the PDA. And the reason why this is a problem is, now I have my phone here. If I let somebody borrow it, they can literally steal all the passwords that are in plain text within 20 seconds by just plugging in a little card into the top, letting it run an auto-run feature, and there goes my security. For any of those devices, my passwords, FTP, so on and so forth. But not all programs, thank goodness, use plain text passwords. For example, Project Master encrypts the user and password, places it into the data file. But if you forget the username and password, there's this little feature called Forget Password down there, where you basically type in your favorite hobby, and then it gives you the username and password. But what if you forget that? Well, inside the data file, they tell you that value in plain text. And at the bottom there, Shmoocon. So, I mean, they might as well just, take that value, plug it back into the answer, and now you have the username and password. So it's basically plain text anyway. And it's not just the data files that are plain text. NVIDIA is a great example. They secure the username and password, drop it into the registry, When you're executing it, they unencrypt it, they paste it into a URL, and pass it to NVIDIA as plain text. So now NVIDIA has your eBay username and password, and so does anybody running a wireless sniffer. These other two programs are the same kind of thing. You've got to be careful when trusting any kind of wireless or network device that's sending username and passwords. You can also access the plain text data inside of memory. For example, these programs do secure the data on the device, but inside the data file, when you load it, it decrypts it and places it into the memory. So in this case, you just basically look for the string compare, mem compare functions inside IDA, and here you go. This is an example right from Project Master, and you can see the top one is my username, the bottom one is my password. The value I type in, or poke in, I should say, if it matches the plain text version, it'll pass through. Well, you're tied to, well, you're basically, when you're debugging an application, you're tied to that little space for the application itself. You can jump into other memory ranges, so it depends what you're looking for. Like you can jump in the core DLL, you can poke around other applications, but you'd have to know what you're looking for if you're trying to get into it, because it shows up in variable places, which is a problem with buffer overflows. We'll get into that later on. Anyway, here's the password in plain text in memory that is being decrypted for us. So if you can steal the password or the data file, you can steal the password. Okay, anybody have a laptop up and running? Here's the first question. What encryption does Password Master 3.5 use? And whoever gets me the answer first, it gets a book. Which, if you have a laptop up and running around here, well, not many people do, unless they're running Blackjack or something. I mean, Backtrack or something. So anyway, Password Master, you can completely bypass the encryption scheme on it by overwriting bytes in the header of the data file. In this case, you're overwriting bytes 50 to 6F, and with a value that you know. And when you type in, I mean, you can just take your own data file, pull those values out, plug it into the value you don't know, or the file you don't know, and the file opens up right for you. And if you don't put a hint in, then it'll just simply open up for you anyway. So, is anybody looking for that one? Oop. You're looking? All right. It's not even a type of encryption, it's a strength. All right, you got it. So you can come on up and get your book. So yes, it supposedly uses 128-bit encryption. They sell it, they specify it, they say this is really strong encryption. I don't know what the encryption is actually encrypting, because you don't need it when you might be encrypting the data based on a static password. I didn't look at that depth. But anyway, all these other files, all these other file programs, they do the same thing. You can just simply overwrite values in the file, and it'll open it up for you. It's not just the files, but you can do the same thing in the registry. Simply overwrite, flip bits, delete registry keys out, and the file opens right up for you. Now you can also bypass the protection schemes completely using a debugger. Now all the previous plain text debugger programs are vulnerable to this too, but CodeWallet is a special one. It is, again, it's a credit card, bank data, financial storage, not the kind of thing you want to fall in the wrong hands. It was vulnerable to the overwrite of the header of the data file, but they fixed that. Unfortunately, here's the shots of the values where that fell victim. Unfortunately, you can completely bypass all protection by using the memCompare function again. R0 is what it should be, R1 is what is entered in, and R2 compares the sizes. So if everything comes back 0, you're okay. Here's an example. R1, R0 are holding values pointing to addresses in memory, and here's the actual function. Now after the memCompare function goes, you can see right after it there's a compare opcode where it's comparing 0 to what's in R0, which is either going to be 0 or it's not going to be 0. If it's 0, then everything continues forward and all things will go. If it's not, then you would think it probably breaks out somewhere and goes somewhere else in the code. Well, here are the two values. They obviously don't match. So the result is this. It's not a 0, but you can overwrite it. In which case, the file opens up like it wasn't even protected in the first place. Now, it's not just security researchers that notice this. AirScanner tries to keep track, who's downloading their software, cracking it, that kind of thing. So I'm looking around on Ware's board, and sure enough, I see this CodeWallet, and it's like, hey, well, let me see what this guy has to say. He discovered it too. So he not only released a cracked version of or CodeWallet, he also released a version that completely bypassed all protection, and then proceeded to basically tell the world about it. So I mean, it's pretty bad when the Wares community is even noticing software security sucks. So speaking of poor software protection, and again, this all assumes that the people are really trying. Basically, software protection is something to keep people honest, but some of these are so funny that I just had to throw them out here. One company, Windows Mobile software, 80 plus titles are tied into this little DLL file, which isn't actually a DLL in a normal sense of the word. It's a plain text file that they just store their information in and try and hide it. If you delete the file or set read-only on it, you pretty much your trial software continues on forever. The other thing you probably shouldn't do is post a source code for the activation key, and that's what GoDB did inside their. If you follow the path through their files and programs that they have, you can get that activation code. It's not the key itself, but it's one step closer. Pocket IRC, well, they're just funny. You guys, I'm going to turn you into a bunch of crackers, if you're okay with that. The first one to tell me what the serial is gets a book. You ready? All right, you get a book. Yes, they hard-coded the serial into the program, and not only made it, funny, but the guy obviously has woman issues. Anyway, it's not just previous issues. There's also poor crypto that shows up a lot. And I'm going to start with Pocket Money. Pocket Money is a really, really bad algorithm. First of all, it's only 8 characters long, so your password's limited. And what they do is they take the password, the value you enter, and they use it through a jump table. So for the first character, it actually goes through this AND function right here. Actually, that's the second character because it starts with entry 0. But for each character entered, it passes through an AND opcode, which then encrypts the value and then stores it or unencrypts the value. So here is at the bottom, you can see an encrypted value. You can see 2 lines down, the decrypted value. How many of you can convert the hex to ASCII pretty doggone quick? Because if you can figure out what the key is, you get a book. I'll leave it up there for a couple seconds. And yeah, come on. See the people straining, thinking, reading. Anybody got the first letter? The first actual ASCII letter. What letter? I'm looking at 70. The middle line. I should tell you which line I'm talking about here. The middle line is the actual key there. So the first character is a knack. It doesn't count. But the second character is 70, hex 70. What is that? I really want to give a book away. I don't think so. It should be lowercase p. Second letter is lowercase m, then O, then N. Money. All right, you get the book. Yes, the password they're using to protect their data is p-money, and through an ad algorithm. So it's not just p-money, but BullGuard. They encrypt their user information, and here you can see it in the file. The actual password is AAAA, which you can see at the top line there. In hex, it's the following. But it's so bad that in theory, if someone wanted to make a key a decryptor, it could be done in a Perl script if someone wanted to do that. Now, one pass. These guys caught our attention, not really for any obvious reason. But the Pocket PC Magazine Award is probably one of the bigger things in the Pocket PC community. They won, we didn't. So does anyone notice a pattern here? And this is a password key for 22. 4, 5, 5, 6, 6. What's the next character? Let's go do that again. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Yes, 7, 7 is the next key, but what's the next character is changing there? 0 what? D? You right? And you get a book. Good guess. Yeah, 0D. They shouldn't be stored in a registry. It shouldn't be that easy to crack, but it is. So it's not just information disclosure. There are lots of programs outside of that that are vulnerable to various things. Sure. Pocket Internet Explorer in the older Windows Mobile 2003, which still is about a 25% market share according to the way we see downloads, it'll instantly crash on a cascading style sheet error. Mike Kemp recently released something on Windows Mobile 5 that is in a WML file. It doesn't actually crash the the Internet Explorer, but it will freeze it for about 5 minutes. And you could probably extend that. But what's really interesting in the old version of Pi is that DOM is completely broken, or maybe doesn't even exist at all. Using JavaScript from a public website out there on the internet, you can basically have JavaScript that can read the files, make the files show up in frames. You can read those files in. You can do all kinds of fun things. Now, besides that, there's cross-frame scripting, which, if you go way back, this is where cross-site scripting got its original name from. And that's where you can have a domain in one frame and a domain in a different frame, like eBay over here and CNN over here, and eBay can actually write to CNN and read to CNN's page, which means you can overwrite any of the content on the page. Now, Johnny Long, his website wasn't hackable or anything, but inside Pi, this is what I was able to do: add my own little note to his old site. Thanks, Johnny, for letting me borrow that. And you can see at the top there's other problems, such as the old user pass URL, where you can plug anything in there, and you can also hex encode the URL itself. So it's great for phishers. It's like a fisher's dream come true if they want to target Pi. Now, Internet Explorer local file access vulnerability, about a month ago, you can determine whether or not a file exists. People remember reading about that? Maybe? Well, it affects Windows Mobile 5 as well. And earlier in a talk today, Billy Hoffman gave a great presentation, and I'm going to go see the second one because the first one was so great. He talked about all kinds of things that you can do with cross-site scripting, and you can do port scanning and stuff like that. You can also detect whether or not an application's installed. For example, it's a phishing attack. It's a phishing dreams come true. If they're running script on a site, you can detect whether or not a program is installed, throw up a pop-up box saying, hey, go here and update your information, and now you can pretty much kind of own a person that way. Keep in mind this Flex Wallet program, because it's going to come up later. So that link at the bottom there, it covers a lot of these. Minimo. People I hope are familiar that you should never use Password Manager, right? Because it's very vulnerable, and if you're using a Password Manager in Firefox, you deserve to get hacked. Basically, if you are using it and the same site that has a cross-site scripting bug, the cross-site scripting bug can be used to read the username and password that you have stored in your Password Manager and then send it to somebody else. It was discovered in 1.5 by Arsenic and White Acid. Kind of rediscovered in 2.0. He more focused on the why can't I overwrite and change the action form value and then send something to someplace else. It was supposed to be patched in 2.1, wasn't. 2.2 wasn't. Still wasn't patched in 2.3. But that's beside the point. Minimo is Firefox for Windows Mobile, and it's vulnerable too, and still not patched. So this kind of illustrates that if something affects the big brother world, being the PC, Microsoft, Windows, it's probably going to affect or could affect the mobile world too. And it's a lot harder to update one of these guys because you got to flash the ROM. Not just browsers, but web servers are vulnerable too. Pocket HPH is one of my favorites. It's the PHP parsing server for your Windows mobile device. Now keep in mind, these aren't, you don't normally run servers on here. It can be done. I've actually run a server on here for a while just to see what would happen, and it handled it just fine. But there aren't that many out there, like 6, and 4 of them have bugs. Anyway, directory traversal, full-blown index access list, everything else. But you can view all the PHP source code by just putting an S on the end of the file name, which kind of defeats the purpose of having PHP in a way. Anyway, CE, HTTP, here's the basic browser. Here you can bypass and gain directory traversal to pretty much anything on the, it's kind of limited in some ways. So in this case, you can gain access by using a bunch of slashes to the access log.txt.
Assuming most people aren't crazy enough to run a server, have you run into software that actually embeds the server within it for some random purpose such that you might end up running one without realizing it?
No, not a web server. Oh, well, there are other services that run on it. We'll talk about that later. The what? Well, it's not quite a server. It's a live, in Windows Mobile 6, you mean? It's a live thing that kind of operates within the device itself. I took a look at that too, but I didn't find anything. I didn't spend a whole lot of time on it, but if you know something, that'd be nice to know. Anyway, so you can get access to the log file, see everything, all the pages that are on the device itself, and use it to your advantage. VxWeb, Pico server, or you can do denial of services via buffer overflow. We'll talk about that later. Now there are other fun things you can do with Windows mobile device. There's games that run on here that allow you to post high scores to the internet. But before you can post it or take it out of the device, you have to encrypt the score, encrypt your name. Well, these are all vulnerable. You can basically make up your own score and post it. Supposedly, if somebody would have done it, not that I would have. And these are examples which you can get the slides and look at them yourself because I don't want to be tied to it. Speaking of cross-site scripting, and I'll plug this now, working with these guys, huge players in the cross-site scripting world and the web application world. I'm more of a technical editor, providing a couple of things of content, but when you start hanging out with these guys, you start looking at everything through different eyes. And I started thinking, Windows mobile device, there's a whole segment of users out here that are going to focus on one particular niche of the web world. So I started taking a look to see who was vulnerable, and yeah, pretty much every single Pocket PC-based website had cross-site scripting bugs. And it's not just cross-site scripting bugs. This one's my favorite, probably of all of them. Singular Express Mail. If you go out and buy one of these phones with a day package, it comes with this thing called Express Mail, which allows you to log in via the web, look at your documents, and also tracks your get your email for you. Now, it contains several directory traversal bugs, which allows you to gain access to pretty much any file on the server it was installed on. Not a big deal for the personal client, but this software is also used in the business world. But it's also a cross-site request forgery playground. And I would do this live, but a movie demonstrates it much better. Assuming my laptop will work. It's really groaning under the weight of so many things right now. So here is Singular's Express Mail getting owned by Script. And what you're going to see here is a blank page at first, which is where everything's going to be dumped to. And what I'm going to do, this is the page everything's being dumped to. And what I'm going to do is steal the entire inbox with JavaScript. So we log in, type our password in, it'll show us our inbox. We'll go to an actual email. We'll open up the email. Inside the email is a JPEG file. Not really dangerous. The JPEG file is actually script, though, because in Internet Explorer, it doesn't care what you name the file. It looks at the file itself. So you can put script in a JPEG file, and if someone opens the JPEG file, it'll execute the script. So that's what I'm doing here. And what it does is it uses frames. I could probably speed this up with Ajax. Maybe I'll do that for version 2. But basically, it frames. And it creates a dynamic frame, loads the inbox into the frame, sucks everything out with inner HTML, parses it out, locates the URLs for each individual email, loads each email into the frame, sucks each email out, stores it, and then when it's all done doing that, it'll then submit the entire contents to an offsite server. I mean, the user really has no clue what's going on right now. And again, this is pretty slow because I'm using actual frames, because I'm more old school when it comes to this stuff, but you could definitely speed it up with cross-site scripting, with Ajax. So we wait, and it should be about done here. There. And now the damage has been done, and we'll take a look down here at our bucket. And you can see that I also included the ability to capture the cookie. So, even if you don't get the emails, you can still get the cookie, which that means you can log back in, and you can then steal all the documents too. So there's the cookie, there's the email. The point is, Windows mobile devices are not just changing the landscape as far as device world, but it's also changing the landscape as far as what we can do on the road. And this is one example of where not everything's thought out. And to make things even worse, Singular actually gets their software from 7 and rebrands it. 7 provides the same software to, 64 countries with 115 leading mobile providers. And you can see the list of providers right there. So I imagine it goes way beyond Singular and could be a big problem. So you can also, you're mentioning services, and here we'll have an example, if my computer can handle it. Yeah, you try running 4 virtual machines on a 8200 Dell, and things tend to go slowly. Cancel that for now. Now I'm going to run this out of a program called Linux, and basically what this is going to do is going to spawn a password box directly onto the target machine, which can be done from anybody anywhere in the local network. So here we are, it's writing the packet, and there you can see the password box showed up. Again, no interaction from the user. The password box shows up. What are 99% of the users going to do? Oh, well, what's my password? I guess I'll type it in. And here you can see back here in our Linux, it gladly took our password and put it on the screen. So that's just one thing I want to do here. Next, let's jump over to Wi-Fi tunes. This is hilarious, and I kind of get away from Windows Mobile here. But Wi-Fi tunes, it's a great little listener for iTunes. You can listen to your, it's kind of like a client, right? So you can listen to your shared music. Here's Seth Fogie's music. And I discovered that you can do fun things like spam the whole entire network with fake music lists. And it goes way beyond that. And this doesn't really have anything to do with Windows Mobile, but it's too freaking funny. And if has anybody seen this before? No? Oh, it's funny. Just take my word for it, and I'll show you why. Not that window. CD. And let's see, Perl iTunes.pl. Okay, so the MDNS protocol is what basically iTunes uses for propagating their shared music list out in the network. You can see here on the kind of like inner window, there's one there called My Shared Music, which is actually being created from the outer box. What I'm going to do here is add 30 new lists that are going to last 10 seconds because you can control how long each list lasts with the time to live variable. And I'm going to burst it onto the network. Now I'm using Nemesis to basically spoof packets. And there you go. Bang. Imagine if you could make a lot more. And if you're on a heavy, like an advertising department network, they're all running iTunes, you can really have fun. So that's one thing you can do. Let's see here. iTuneU.pl. Okay, so you can not only make mass hysteria, you can also make new lists. And I'll just do 100.1. Let's see, 89. And I'm going to, my purpose is to replace, but it actually creates and test. I forgot Perl, didn't I? iTuneU. Okay, fat finger up here. And we wait a second or two, and you can see a new one just shows up. And it'll last there for a while. But you can not only just create lists, you can kill lists. And this is really funny because in the middle of a person listening to their favorite sock, they can just, oop, bing, gone. So let's just go over here and replace that. And I'm actually going to kick that list off. And you'll see my shared music go away. So with this, you can do all kinds of things. Kill lists, make lists go away. I mean, it's just great fun. I actually wrote a script that the text when an iTunes client comes on, it automatically kicks it off. And then nobody has access to it anyway. The advertising department didn't like that script. So let me get some of my system resources back here. Because my computer just can't handle all this fun. And while that's shutting down, let's go back to our slide. Okay, so that's that. And there's other programs out there that have issues too, such as Remote Keyboard. This runs a listener on the PC, which runs on 8123. If you connect up to it with a Telnet client, it'll pretty much dump the entire clipboard contents out into the network for some buggy reason. Pocket PC, 2PC attacks. Now let's say you're a pen tester or an attacker. You gain control of the PC. Well, don't just think inside the box, think outside the box. Look for peripherals that are attached, such as the active sync connection, and connect up to your PDA that's synced up to the device. Pull everything off, execute code, whatever you want to do. There's lots of programs out there to do that. I wouldn't be surprised if somewhere in the future this might show up in a botnet program that detects whether it's there. Well, we already saw how many programs are out there that don't really protect your data, but people think do. Grab one of those files, and now you have access to credit cards and all that information that people are storing on these personal devices. Kiosks. You can also turn these devices into kiosks. And in this case, SBP Kiosk is one of those programs. Now, I'm not knocking SBP Software House. They're probably the best ones out there as far as they go. They produce a lot of great programs. I've been playing cat and mouse with them over the different generations. And initially, you could reset the password by just sticking in a card and gain access to the device. Then you could execute your whatever. They disabled the auto-run feature. You can then run any executable you want through the Internet Explorer bar. Finally, in this last version, they locked all that out, but then I discovered that you can gain access to the registry settings setup file that contains the password in the first place and still get into it. So the kiosks are kind of tricky, as with any device, and be careful trusting them solely in the real world. Now, malicious code mods, I bring this up. I talked about in the Black Hat, but it's worth it because I'm going to kind of integrate into the talk a little bit. It's very easy to change the code on this, and because there's only a little icon that shows up down in the little bar, if you just simply change that little shell notify icon, you patch it out, well, now you have an instant backdoor, instant Trojan that is 99.9999999% valid, which is going to be really hard for an antivirus to build something for it because it's not an invalid program, really. Now, BullGuard AV, this one's hilarious. This is their virus database file. for the mobile, Windows Mobile. What platform does driver A run on? Try a different one. What platform does Kabir run on? All right, you get the book. Symbian, yes. I suppose we're just making a shortcut here, putting Symbian, testing for Symbian viruses on Windows Mobile because they won't run anyway and have no point. But what's more disconcerting is that it's completely plain text, wide open. Most antivirus vendors try and obfuscate it a little bit, encrypt it completely, and that long string is actually the byte string that is used in the searches. So I decided to test something out and added my the Shmoocon virus. What does those 4 characters represent? The PE header, first 4 bytes of every DLL and EXE and control panel and cab file on the device. So if you can get a buffer overflow in there or just overwrite it with, just inject your own any which way, many ways to do it, you end up getting a lot of viruses that you can, automatically delete. I have 81 viruses on my device. That's a whole lot of viruses. So here you have the Shmoocon virus. To make matters worse, this same basic package is available and rebranded with other vendors. Now, the Windows wireless, if you're into wireless networking, cracking, hacking, whatever, you're probably familiar with Karma. It basically instantly listens for probe requests coming from computers, instantly establishes, well, turns itself into that kind of, and then establishes a connection to the device, creates pretty much a backdoor unsuspectedly to the user. Well, the same thing applies to these devices. I have a card that you plug into one of these. It's a Dell 802.11b card, and it sends out probe requests for the word Dell, even if I've never connected to the word Dell before. Now, the Axum sends out requests for 32-byte kind of random values, which are it's a driver-related issue. Again, I never put those in there. Now, it also sends out requests for the ones I did put in there, so it's vulnerable to that too. But kind of to make it worse, the Windows Mobile user is never informed when the connection is established. Usually at the top, little icon flips, but it doesn't in this case. It just stays. And there's no request saying, hey, do you want to connect to this network? Which is kind of an additional security feature in Windows Mobile 5. Now, you can remotely control these various other ways. The Pocket Transfer, LapLink, Pocket Controller, they're all programs that you can connect up your PDA over a network, and you can kind of control it and debug things and stuff like that. But there's no authentication. You can emulate the whole connection. You can basically just send it a string of data, and it'll instantly soft reboot it or whatever. Now, how about last year, the VNC bug that was out, the one where the client itself was insecure, and it basically allowed you to instantly gain access to any VNC server. Remember that? Nobody made a Pocket PC version that was released. I'm really disappointed in that. At least not officially, but it might exist. Anyway, Windows Mobile 5 code signing. This is what makes Windows Mobile 5 secure. Its primary, you can read it, defense against malicious code is not to run at all. So when you try and run something on a Windows Mobile 5 device, it'll say, hey, are you sure you want to run this? It could be malicious. Unless it's signed. And if it's signed, then it will instantly go. There are 2 different ways of looking at this. Smartphone, 3-tier. Windows Mobile phone, 2-tier. 2-tier says it's either untrusted or it's trusted and can gain access to everything. Smartphone says it's either untrusted, it's kind of trusted, where we'll let you gain access to most of the stuff, and it's fully trusted. To get fully trusted on one of these guys, you've got to have the program signed with the certificate matching that's installed on the device. The vendors do have a bunch of certificates on here, so you can do that. But you can also create your own certificate and sign your own your cab files. And if you can install your certificate on here, then you can install anything else on here as well. So here are the ways that we can bypass Windows Mobile 5 code signing. First of all, if you have a buffer overflow, it's going to run in the context of the executable that you're taking advantage of. So now you can do things like disable all signing via registry hack. You can also spoof a user with a mouse event. You can sign your malware too. That's another approach. So let's break out of here and let's actually look at Windows Mobile 6 Professional Emulator. Here we have MessageBox. I click on MessageBox and it is not allowed to run right now. Okay, so there we go. It's not running. So I'm going to say no. Now what I'm going to do this first round is I'm actually targeting a program called PAM. And PAM is a stock program. You basically get a list, you download it, and it updates it. So it'd be pretty easy to say, hey, get this great list. It has a top 500. However you want to get in there, it doesn't matter. The first approach, though, I'm going to take is I'm going to attack it from the PC side. I found a device. It's a Windows Mobile 5 device. I want to execute my own executable on there. I want to be able to attack it. So what this little guy does is using those methods I talked about. It'll first copy over the buffer overflow data file, the data file that contains the overflow. Holy cow. It will then copy over the FTP server that's been made invisible. It will then start the PAM program, which will then read the overflow file and execute the overflow code. And then it will start the FTP server. In the overflow file, there's actually a sleep command, which then waits, allows the FTP server to execute, and then the rest is history, as you'll see. I should probably call this look ma, no hands, because that's basically what happens here. And as long as everything's working right. Demos, you gotta love them. All right, copying, it's executing, and it's executing. And over here, you can see, look, no hands. 3, 2, 1, oop, there it goes. And off. And now we have an FTP server installed backdoor, which will always run every time the thing's booted. Okay, so that still doesn't take care of a problem with the message box, but have no fear. Let's go to round 2. And this contains code that will just simply copy over the overflow file containing the buffer overflow code. Now this buffer overflow is funny because, I mean, you can do a lot with overflow code on these devices. It's on there. What this overflow does is it, oops, wrong one, is it first creates a shortcut to the executable in the startup folder. It then flips the value in the registry saying, all right, all executables are allowed to execute. It then takes inside the actual overflow, it's pretty big, it then copies out bytes that are in the overflow, creates an executable inside the root directory, and then executes that file, which is now allowed to execute because I flipped the value in the registry. Got it? Yeah, it was real fun to put together. Oh yeah, I want to go up a level so you can see that there's nothing up my sleeve here. There's no executables there, and I'm going to execute PAM, and oh, Shmoocon. There it is. I just completely bypassed the Windows Mobile 5 code signing. And just to prove that the O file really is it, there you go, Shmoocon. And just to prove that we are now allowed to actually execute code, let's go back to the message box, which is now allowed to execute. So yeah, those are 2 ways using buffer overflows we can completely just code signing. Now these are different files. You see that Flex wallet? Remember I mentioned that? There's another. You could spoof some, or you can phish somebody, get them to download your data file, get the code to execute. Now you go on the device. More examples that have actual working, local exploits. Windows Mobile Smartphone. This is a pain in the butt. Grandly show. Not impossible, but a pain in the butt. Here we have Windows Mobile Smartphone device emulator. I'm going to look on the file system. You are severely limited as to what you can do on a Windows Mobile device. You can't write to memory, which means you're limited to functions that have 4 parameters or less. So I'm using the copy file function, which only takes 2 parameters, in file, out file. And you can see here that there's a test exe right there. And what I'm going to do is copy it and using buffer overflow. Oh, crud, what did I do? Okay, and back home again. And Flex Wallet now, this is using Flex Wallet as an example. And here we go. And yes, it's a demo. Thank you for letting me do this for 8 more days. And I'm going to open an existing file that is placed on there one way or another, and I conveniently label it copy file. And it'll open it and kill the program. Because there's an exit thread function, it just basically gets it out of there. And now we go back over to our file listing and refresh it. Oops. I hate smartphone. I can't tell you how much I hate it. I don't know why they was invented. The Windows Mobile device is so much more fun and friendly, and it has that screen you can actually touch. So here you can see it actually worked. It did create a duplicate of the file. So you can do buffer overflows on a smartphone platform. I don't think anybody else has ever done it, so this might be a first as far as Windows Mobile smartphone. You have? Oh, you didn't raise your hand? Oh, okay. Say if you did, I'd like to hear about it. Flex Wallet was a great example. It actually has the overflow in the DLL, not in the main file. But IDA works rather well with that. You can load up the DLL. It'll sync to the main file. You can control the figure. You control the function, and you control all that in the options. And the overflow itself, we found because inside a data file, you had to open up with SQLite. And then you were able to put a long string in there, and basically that's where you could create the overflow. But there's a lot of things that make it hard. So the remote overflow is not probable. I'll pretty much just say that right now. And it's due to memory offset issues. When you are coming at it remotely, you can't send all bytes because that'll kill your connection. It won't work. So you got to be able to target the specific address that the code is running in. But it's a guess. You don't know what it is. So you might just crash the program, or you might get lucky and run it. And that's what Colin Mollimer ran into with his Tmail exploit. Not only that, there's addressing issues. I forget, but I'm pretty sure the addresses on this device aren't the same as the addresses on this device. So you got to target it kind of per device, although all Windows Mobile 5 devices like this have the same address that I have in my possession. So it's slightly a guessing game, slightly not. But these programs here are vulnerable. They all have remotely exploitable. Yeah, they all are remotely exploitable. Now, there is another variation of this, and that the remote buffer overflow exploit could be put in there as Unicode. And that makes it even more challenging. It'll DOS the service right off, but it probably won't get remote code execution because you got to be able to either get access inside the device where memory kind of fits that format, or you redirect it to memory that fits that format and then back into your shellcode. Again, these two are examples. So you can get up and running. Oh yeah, I want to do this too. This will take me a second. And Pam. So I have my device here. First, I need to kill this. I think I'll just uncradle it. Here you can see the device emulator is great. You just like right-click, uncradle, and then it's no longer cradled. You can get all this, the Windows Mobile, close that. The Windows Mobile SDKs are free. Visual Studio 2005 has 90 days on it. And what I'm going to do here is demonstrate a remotely exploitable buffer overflow on this device and do a hard reset. But as you will see, hopefully this thing will sync up. It's overflowing the FTP server that I talked about earlier. This is a good one because it's pretty reliable and it's great for demos. All right, it's connecting, and I'm guessing it's in address range 18, blah, 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 blah. But there's no guarantee of that, which is why I have to check this to make sure it is. Yes, cancel. Okay, okay. Okay, you're connected. While that's loading, again, you can get all this. You set up the ActiveSync 4.5. You use DMA as the method to connect up to it. And I haven't seen an obstacle so far. You can completely control the emulators from being wide open or being super secure, so you can change all those settings in there. In summary, the Windows Mobile software is kind of risky. You take a chance because you can't trust the vendors, as I kind of demonstrated. It's not always easy to test the programs. There's not really many people out there looking, especially compared to the PC software community. And code signing is really only as good as the software. But let's jump back over to here and see if our values have dumped in, and they have. And what I'm looking for is FTP server, and it's running in 18. And I come over here to my command prompt. Here you can see the program, and PDA exploit 190.200.1.85, and it's running on port 21, and the offset's 18, and device, 18 device type is 1 in this case. And it will take a good 15-20 seconds for this to go because the computer's slow, and eventually you'll see this thing flip off. So, there it goes. It just flipped off, and about 2 seconds you hear it, ding, which basically tells you your device just got hard coded, jammed, dead. It's owned. Yeah, hard reset. I gotta reset that thing up again. So, special thanks to everybody on this list and many, many more who have been part of the community, looking into this stuff and working on it. Any questions? Somebody didn't get a book? Yeah. I'm sorry, what? Oh, you mean inside the, well, they've done a lot of fixes in Windows Mobile 5. The platform itself, that's what Windows Mobile 5 did with the code signing. What can you do when a third-party program is installed on the device and it's vulnerable? There's not really a whole lot. I mean, you're limited. Microsoft is limited. They got to have usability versus functionality and security. So, I mean, I don't blame Microsoft for this. Windows Mobile 5 is a billion times more secure than previous versions. The people that did the code review know what they're doing, knew what they were doing, and I trust in their work. There are some minor bugs, but nothing like in previous versions. Anyway, you can have a book if you want, because you asked questions. And I don't have any more books, so that doesn't mean you have to ask more questions. But anything else? Yeah. It's dangerous always recommending software because there might be something I don't know about. But e-wallet, I think I tested. If you're looking for that kind of genre of program, all the other ones are open to. I mean, really, it just depends what kind of software you're looking for. Of course. Yeah. I know some of the software that I've tested actually have a PC version and a PDA version. So I'm not a PC hacker in that regard. I like the Windows Mobile community, Windows Mobile stuff right now. But I would probably guess that a lot of the programs suffer the same kind of consequences. I couldn't answer that, honestly, because I haven't looked into the Linux software to really say so. The core services are going to be really hard to get into because they're running in protected environments, or it's ROM, you know, it's not RAM. So it's not as easy to exploit, although Colin Oliver did it with his Tmail exploit, because that is running as a core service. So I'm not saying it's impossible, but it's harder to debug, too. I know there are policies out there, and that's one solution you can do. You can lock down a PDA with policies. You can make it much more difficult for people to install software in the first place. Again, all these things I've shown today were really third-party applications. If the third-party application is part of the equation, then you're pretty much, I mean, you're hoping it's safe enough. All right, thanks a lot. Hope you enjoyed the talk. Hi. Thanks. Yeah, I'm going to put up a hair scanner.